Today we're going to be doing our Chapter 10 assessment, and we're just going to be doing, and I've decided to do 4 problems is what you need to do, 88, 89, 90, and 91. So let's go ahead and look at mine. So on page of our assessment, Chapter 10, on a book, and I shouldn't have done that. So you're going to go to the assessment page here, and you're going to go to the one that says mixed review, which is right here, and this is the ones that we're doing today. So let's look at the ones that we are going to do. So the first one on question number 88, it says ramp. Azra has gotten a piano at 2.0 meters high platform. She can use a 3.0 meter long frictionless ramp or a 4.0 meter long frictional ramp. Which ramp should Israel use if she wants to have the least amount of work? So, either ramp would work, but only the vertical distance is important. If Israel uses the long ramp, she would require less force. The work would be the same. Okay? 89 says, Brutus is a champion weightlifter. He raises 240 kilograms of weight. So that's my force. And the distance is 2.35 meters. And we're going to times that by gravity. And it says find the work. So to find the work, we're going to take the force times gravity times distance, which is 5.5 times 10 to the third joule. B. How much work is done by Brutus on the weights, holding the weights above his head? Well, there's no work because he is not moving, okay? He's just holding it over his head. How much work is done if Brutus's weights lowers them back to the ground? Well, that would be D would be the opposite of the input, and so that it will always be, since this is a positive 5.5, this would be a negative 5.5. Does Brutus do work if he lets go of the weights and they fall to the ground? And no, he exerts no force, so he does no work. Okay, so that's kind of giving you the definition of what work is and what work is not. Number 90, an 805 Newton horizontal force, well, that's our force, okay, needed to drag a crate across a horizontal floor at a constant speed. And it's drug the crate using the rope at a 32-degree angle. So to be able to do this in our thing here, this is an angle. So remember, when we're doing our math, first thing that we'll need to do is we need to turn it on. Okay, so the first thing we need to do is change our mode, and this is going to be in degrees. Remember, go down and change it degrees. So alpha y, enter, 805 on the top, on the bottom. We're going to do cosine 32, close, over, enter, and I get that answer there. 949.2386147, which is the right answer. But then I did mine in scientific notation. So when I did that, I got 8.49 times 10 to the second. I rounded that to 8.5 times 10 to the second. 4B for 90. How much work do you do on a crate if it moves 22 meters? Well, we're going to take how much the mass is again. The force is 805, times it by 22, and we get 1.8 times 10 to the fourth. Make sure that you change your mode back down to radian again, because if you don't, you'll have it in degree. And so you're going to do 805 and 22. And then I got 1.77, which I rounded up to 1.8. Okay? And for C, if you complete work the job at 8.0 seconds, how much power is developed? So to do power, we're going to do the work that we have here, divided by the time. So that says that it is alpha y, enter, 1.8 times 10 caret 4 down. And that was 8.0 seconds, 8.0 seconds. And that gives me 2.25 times 10 to the third power would be a correct answer. And if you decided you wanted to have it in normal mode, and it's 2250, which I put down 22,500 kilowatts is my answer. The next one on 91, a dolly and a ramp. And so it says here, a dolly is used to move a ramp 115 kilogram refrigerator up a ramp in the house. The ramp is 2.10 meters long and a rise is 0.850. The mower pulls the dolly with a force of 946 newtons parallel to the ramp, and the dolly and the ramp constitutes the machine. How much work done is on it? So for work, we're going to do our force times our distance, which is 496 times 2.10 meters, which gives us 1.04 times 10 to the third. What is the work done on the refrigerator by the machine? Well, that is going to be the height that is raised, which was 0.850 meters. So we're going to take our force times our gravity times the height meters for our D here, and we get 958 joules. And then what is the efficiency of the washer? You're going to take your 9.8, you're going to multiply that by your work, which is 1.04 times 100, and you should get 92.1. Now, if you would like to do question 92 and 93 and 94, you're more than welcome to do that if you'd like. I just feel like those were pretty good questions that you need to answer, and that should be all that you need to do today. Now, tomorrow you'll have your test. Please make sure that you are keeping up with everything. Make sure you're submitting everything. Make sure I'm grading everything for you. And I hope you have a great day. Bye.